Good morning.
Good morning.
Good morning.
All right, so let's see. Who is absent there in Joe City? It looks like Jay and Avery. Anybody else? All right.
Caitlin's not here.
Caitlin, anybody else in Holbrook out today?
No, it's just her.
Thank you. All right, so today we want to finish 7.3 and start in on 7.4. But before we jump into the lesson, I do want to apologize for the grief I caused you about quiz 7.2. Apparently, we're going to take that in March sometime. I don't know what happened. I guess we're just going to delay it for like a month. No, it's actually, I'm kind of surprised that kind of stuff doesn't happen more often, because I literally have to go through so many different clicks to make these quizzes come up perfectly. And anyway, but so we're going to have, did anybody have time to take it? Because by the time I caught it, several of you, I think like Seth and Kinsley and a couple of you had emailed me or texted me. By the time I fixed it, the period was over half over. So I wasn't sure if anybody would even have time to do it. So, what do you think would be the best way to make that up? Do you want to try to make it up individually on your own time and let me know, or should we just add it to the quizzes next Wednesday? What do you think?
Just individually, because I don't want to have like 3 quizzes next Wednesday. That'd be a lot.
All right.
We would much prefer to have it next Wednesday.
Yeah.
You'd rather do it next Wednesday?
Yeah.
Okay. The thing that I will say this about it is that if we put it on the docket for next Wednesday and you're not able to take the second attempt of all of the, whatever quizzes, 7.2, 7.3, 7.4, then we could do that individually. So we could just sort of see, you do whatever. I don't know. What do you think? Any other comments, input? Okay, so let's just take a vote, and I'll just go with the majority. So all in favor of just having the 7.2 quiz next Wednesday during our regular.
Keep it down.
What? I'm sorry, I missed that.
Mr. Strong, what about if we take the quiz that we missed on Friday tomorrow, since we don't have class?
Well, see, that works great for Holbrook.
Oh.
So I guess I could do it that way. I could split it and have Holbrook take it tomorrow, and then Joseph City take it on Wednesday.
That would be awesome.
Yeah.
All right. So everybody happy with that then? All right, let's do that. Okay. That way Holbrook gets what they want, spreading it out. Joseph City gets what they want, not having to schedule it on their own time. Okay. So, okay, that's perfect. And that's why I get input, because we're all collectively.
I have a quick question.
All right.
Could I, if I were to come in, do we have intermission tomorrow? Oh, never mind.
Okay. Yeah. Now, if I can anticipate what your question was, is I know they have enrichment some days on Fridays. Could you ever come in and take a quiz? As long as your talent aid is there. I don't know if they have to come in on Friday or not. So, but if there's ever a time when they do or somebody does, or like, let's say that, you want to take it in the library and work it out with Miss mils, then that would be fine with me. You could just say, hey, I'd like to open up the second attempt on Friday at 10 o'clock or whatever. Okay, we'll work that out. Okay. But you're saying that there's no enrichment this Friday anyway? Okay, all right. Okay, so, all right, well, let's go ahead and get down to business here. Okay, so we are on the product to sum formulas, so part 4 at the bottom of the first column on the back side of the paper. Okay, so the product to sum formulas are used in calculus to evaluate integrals involving products, okay? So, you might say, well, it's kind of interesting that my calculus students we're going through all the part where we've got to use all these trig identities. And I think they're hating the trig more than you guys are hating the trig at this point. So, but that's just the way it is. Now I will say this about so these are the product to sum identities, but they're in a different order that they are on your paper. So, I'm not going to spend any time on this anyway, but on your paper, I think we have them, we use U's and V's. You've noticed this already. And then on this slide, it's X's and Y's. Just each book does their own thing. Okay, so what we're going to do is we're going to write the product cosine 5x sine 4x as a sum or a difference. Okay, so what you do is you look up the cosine u sine v formula. Okay, so hopefully you've written that down. Cosine u sine v is 1/2 the sine of u plus v minus the sine of u minus v. And so then in place of the u, we're going to plug in 5x, and in place of the v, we plug in 4x. All right, so we get 1/2 times the sine of 5x plus 4x minus the sine of 5x minus 4x. So that's 1/2 the sine of 9x minus the sine of x. And if you want to distribute the 1/2, you can. Or you can leave it in front, whichever. But that's it. That's it. This is nice because it makes it so that instead of this product here, we just have a sum or a difference. Okay? And so you might say, well, is it really that much more simple? Well, in calculus, to do this original one, it's pretty involved. Whereas this is super easy. And it doesn't look like it, but the calculus involved is much, much better. All right, so let's have you try that next practice problem. So practice 4A. All right, so Cabri, when you've got it.
Okay, so I got 1/2 sine 80 plus sine 20.
Okay, now this is a theta. So it's 8
Oh.
theta.
My bad.
No. It's good. Some people, back in the day would write their zeros that way with a little slash through it.
Yeah.
Okay. But yeah, that's a theta. Okay. So 1/2 sine 8 theta. And then what was the rest?
8 theta plus sine 2 theta.
Okay.
Okay, well.
Okay, perfect. Okay. All right. Any questions on that? Now, by the way, if it actually was like a 0, an 80, and 20, that actually would be correct because you would still add the angles and subtract the angles. So you would be correct either way. Okay. All right. Any questions on that? All right. Great job. So I like those because those problems are pretty straight up. Okay. All right. Now, the next we have the sum to product formulas. So they can be used to write the sums of trig functions as a product. So here we have the sum. So like sine x plus sine y, and then our answer, it looks more complicated, but it's a product. But it's really not too bad. You're just adding the angles, dividing by 2, subtracting the angles, dividing by 2. Just you got to make sure you're getting the right formula. There's actually 4 of them. Okay. All right. So let's go through an example here. So it says find the exact value of the cosine of 195 degrees plus the cosine of 105 degrees. So when it says exact value, you're not going to use what?
The calculator.
You're not going to use the calculator, okay? So instead, you're going to look for the formula for cosine u plus cosine v. All right? So here we go. So cosine u plus cosine v is 2 cosine u plus v divided by 2 times the cosine of u minus v divided by 2. So now everywhere there's a u, we're going to plug in 195 degrees. Everywhere there's a v, we're going to plug in 105 degrees. So that would give us 2 cosine 195 plus 105 divided by 2, cosine 195 minus 105 divided by 2. So now we work out what's in parentheses, and so we get 300 divided by 2 is 150. 90 divided by 2 is 45. And now we get those exact values from our unit circle. So this would be 2 times negative radical 3 over 2 times radical 2 over 2. And then we simplify, cancel the 2, well, one of the 2's anyway. Radical 2 times radical 3 is radical 6. So I get negative radical 6 over 2. And that's the exact answer. All right. Any questions? All right, so go ahead and try that last practice problem, 4B. All right, so Ricky, when you've got it.
Is it 2 radical 2 over 2? What like?
Okay, so I got just radical 2 over 2. So let's see. So did you get sine 150, cosine 45?
Yes.
Okay, so then the sine of 150 is 1/2. And so the 2 and the 1/2 will just cancel. And then you got the cosine of 45 is radical 2 over 2. So that would be your final answer. So you just have one extra 2 in there somewhere. All right. Any questions on that? Anybody need me to go through it?
Can you explain it, please?
Sure. Okay, so we have the sine of 195 plus the sine of 105. So think of your 195 as u, 105 as v. So now you're looking up the formula that's the sine of u plus the sine of v. So here it is. So in red. So then everywhere there's a u in the formula, I plug in 195. Everywhere there's a v, I plug in 105. So I get 2 sine 195 plus 105 over 2, cosine 195 minus 105 over 2. So 195 plus 105 is 300, divided by 2 is 150. 195 minus 105 is 90, divided by 2 is 45. So now I get those values from the unit circle, and then just simplify, and then I get radical 2 over 2. Okay? Any other questions? Okay, so that's it for 7.3. And so now we're going to start in on 7.4. Now, 7.4 is the last section in this chapter. It's a much shorter chapter. I think it's the shortest chapter that we do. So what we're going to do is, if we finish this by Monday, at the end of class on Monday, then what I would like to do is have the 7.3 and 7.4 quizzes next week, and then the week after have the chapter 7 test. Okay, so that's kind of my plan, rolling ahead. Okay, then actually when we get through like 8.3, when we get halfway through chapter 8, then we're going to take our midterm. So midterm's going to be coming up pretty quick. Okay, so let's just see how we go. All right, so this last section is on solving Solving trigonometric equations. So my big goal today is to relate it to algebraic techniques. Like what would you do if you were solving an algebraic equation? All right. And then we'll do inverse trig functions. All right. So applying algebraic techniques to trigonometric equations. To solve a trigonometric equation, think of the algebraic steps that you need. The preliminary goal in solving the trigonometric equation is to isolate the trig function. So instead of getting x by itself, what we're going to do is get sine x by itself or cosine x by itself. Okay, and we'll go through the same algebraic steps. All right. Okay. So let's say that we wanted to solve 2 sine x equals 1. Okay. So just sort of pretend that instead of sine x, that your trig function is just x. So if we had 2x equals 1, then what would we do first?
Divide the 2.
Divide the 2. And we get x equals 1/2. Well, that's precisely what we do with the trig function. Is we divide each side by 2 and we say sine x equals 1/2. Then what you do is you say, okay, well, what's the angle? See, when we're trying to solve this, we're trying to find the angle that has a sine of 1/2. So it's very helpful to have your unit circle in front of you when you're doing these problems. Okay? So you look at the unit circle and you say, okay, at 30 degrees, the angle at 30 degrees, the sine is 1/2. So the answer is 30 degrees. Okay, except here's the thing. So normally when we're doing application problems, the answer is always whatever in quadrant 1, because usually you have positive values, positive angle. Okay? If we're not doing an application problem, then normally we want all the angles in the entire unit circle that have a sine of 1/2. So can you look at your unit circle and tell me, is there another angle that has a sine of 1/2? Or maybe you can think of like your reference angles or whatever.
150.
So at 150. So that means that the answers are 30 and 150. So we're looking at the angles, and so most of the time that's what I'm going to be looking for is the answers for the whole unit circle. Okay? All right. So go ahead and try practice 1A. All right, Andres. What do you have?
It is 60 and 300.
60 and 300? let's see. So we get, so 60 and 300, let's see, okay. So 300. Okay, so 60 and 300, those are the answers, okay? Those are the answers that I was hoping that you would get, 60 and 300. Okay, so what's all this other nonsense? Well, let me go back a slide here. See, the sine and the cosine, they actually go on forever, right? So if we want to know when is it equal to 1/2, see, every period as it goes around, it's going to be equal to 1/2 twice. And every other period, it's going to go and it's going to hit 2 more times. So if we have an angle that, you know, 60 degrees, it's going to be 1/2. If we go all the way around the circle, and if we add 360 to that angle, it'll also have that same sine or cosine or whatever. So sometimes what we'll do is we'll say, okay, it's 60 plus 360n. That means multiples of 360. Now, normally I don't have you do that. But if you're looking up an answer in the back of the book and they have plus 360n, what they're doing is listing all infinitely many solutions. Okay? So the answer you said, Andres, was what I wanted, 60 and 300. But if you add multiples of 360, you'll get, so at 420, at 780, so on. Every multiple of 360, when you add to it, we'll get another solution. Okay? So what's all this over here? Well, it's the same thing in radians. Okay? So your answer, if you're looking for the angle, you could give me the answer in radians and it would be correct. And then so going around the circle again, instead of pi thirds, I could take multiples of 2 pi, because that's all the way around the circle. So every time you add 2 pi to your answer, you're going to get another answer. Okay? But again, if you'll notice on the practice problems on the paper, if you just look, I'd say between 0 and 360. So I'm not asking you to do this, and I found that students do a little bit better in degrees, so we're going to just keep our answers in degrees. And then if we need an answer in radians, we'll just convert the answer by multiplying by pi over 180. Okay? But so I'm not going to worry about radians. I'm not going to worry about multiples of 360. We're just going to, for the most part, we're going to just look for the answer between 0 and 360. Okay. All right, so we can solve trig equations by taking square roots. So again, the algebra steps that you use, adding the same thing, dividing, taking square roots, all of those are legal moves when you're solving trig equations. All right? Okay, so let's say I wanted to solve let's see, wait, do I have a better example? Okay, maybe not. Okay, let's go back. So 3 tangent squared x minus 1 equals 0. Okay, let's say I wanted to solve that. All right, so again, think of if I were solving 3x squared. So if I were solving 3x squared minus 1 equals 0, then what would I do? Well, first, I would add the 1, then divide by 3, and then take the square root. Okay? So now, when I've got the square root, then I get tangent x equals plus or minus, well, the square root of 1/3 is 1 over radical 3. Now, it's actually easier to leave it like that when you're looking at the unit circle. Because when we're looking at the unit circle, then we're looking for this kind of stuff. Because remember, tangent is sine over cosine. So 1/2 over radical 3 over 2. The 2's cancel, so we would just get 1 over radical 3. So where on the unit circle in the first quadrant do you have a sine of 1/2 and a cosine of radical 3 over 2? At 30 degrees. So that's one of your answers. Now here's the deal on this one. Since it's plus or minus, we're actually going to have 4 answers. Because 2 of them in quadrant 1 and 3 are going to have a positive 1 over radical 3. 2 of them in quadrant 2 and 4 are going to have negative 1 over radical 3. But they're all going to have that 30 degrees as a reference angle. So it's actually pretty easy. Once you get that 30 degrees, it's up 30, down 30, up 30, down 30 from the x-axis. But you can look at them from the unit circle. So what are my answers going to be then? X equals so anybody.
30, 150, 210, and 330.
Excellent. 30, 150, 210, and 330. Beautiful. All right. Any questions on that?
Yeah, I have a question.
Sure.
So I see how you got the 1/3. But how did you get the 1 over square root of 3? Like, I don't know how
You
you got
take
that.
the square root of both sides. So, like, if I were, let's, whoa. So let's do, come on. All right, fine. Okay. We're taking the square root of both sides. See, again, think back to algebra. If I was solving 3x squared minus 1 equals 0, you would add the 1, divide by 3, and then what would you do next?
Well, you would take the square root, but I just don't know why. Oh, because you already took the square root of the 1, that's just 1. That's
Right.
Oh, okay, I see what you did. So
Okay.
then for the sine and cosine, I know that tangent is sine over cosine, but how did you get the 1/2 over square root of 3 over 2?
Well, because I know that when I have 1/2 over radical 3 over 2, the 2's are going to cancel. And so if I look for the angle that has a sine of 1/2 and radical 3 over 2 for the cosine, I just know that that's going to cancel. The 2's are going to cancel. So when you're looking for the tangent, you've got to know that those 2's are going to cancel for all those angles.
So how did you get the 2 exactly? Like, I get that they cancel, so you get 1 over square root of 3.
So do you have your unit circle in front of you?
Yes.
Okay, so do you see at 30 degrees, the y value, the sine is 1/2, and the cosine is radical 3 over 2?
Yeah.
Okay, so then when you do that, so then the tangent is sine over cosine, so the 2's are going to cancel, so you'll end up with 1 over radical 3.
Oh, okay, that makes sense. Thank you.
Okay, and so then the other 3 answers, so again, because it's plus or minus, you're going to have 2 that are plus, quadrants 1 and 3, and then 2 that are minus in quadrants 2 and 4. Okay? All right, any other questions on that? Okay. All right, so go ahead and try practice 1B. All right, so Naomi, when you've got it.
So far I have gotten to tangent x equals square root 2 over 2. That's as far as I've gotten so far.
Okay. So. Actually, let's leave it. Don't rationalize it.
Okay.
Let's leave it as 1 over radical 2. Okay?
Okay.
Because that's how it was originally, right?
Yeah.
So remember the 2's, when you do the sine and cosine, the 2's are going to cancel. So look on your unit circle for the sine to be 1 over 2 and the cosine. Oh, wait a second.
Yeah, but I don't think there is.
Yeah, okay. I didn't. This should have. Let's see, did I. Okay. Yeah, this is gonna require a technique that I gotta teach you later. So let's do this. But I want you to have that example. Actually, let's do this. Let's go back and have you change the. Let's write down this as the practice problem. Because I want you to have one like this in your notes. Okay, can I move it? There we go. Okay, so change the 2 to a 3. And then you can go down and either solve it or write down, this is what we went through to get those 4. So let's just put that down for practice 1B. Yeah, so I'll teach you how to deal with it. See what the one that you did, the answer, I didn't contrive it right. So it wouldn't, the answer that of the one that you just did was not on the unit circle. And so we'll learn how to do that later. I didn't mean to have you have that on that practice problem. Okay? Anybody need any more time on that? Okay. Okay, so to solve an equation in which a trigonometric function occurs more than once, then you need to factor or use the quadratic formula. So it's kind of like this in algebra. If you're trying to solve for x and you have x, more than one term has an x in it, then you have to factor or use the quadratic formula. Okay, so it's the same idea. All right, so let's say I want to solve sine squared x minus sine x equals sine x plus 3. Okay, so we've got 3 terms with sines in them. So the way that I approach it is I just sort of imagine I was solving x squared minus x equals x plus 3. And I think, okay, so how would I approach that problem? What would I do there? If I was solving the polynomial.
Do you put all of it onto the same side?
Yes, to set it equal to 0. Okay, so I would subtract x and I would subtract 3 to get a 0 over here. Okay, so that's the same thing I'm going to do with this. I'm going to subtract x, so then I'm going to have minus 2x and then subtract 3 and then get it equal to 0. So that's what I do. I subtract sine x and get negative 2 sine x minus 3 equals 0. Okay, now I go back to the algebra problem. So if I had x squared minus 2x minus 3 equals 0, then what would I do there?
Factor.
Factor. And what would it factor to, Lauren? What 2 numbers multiply, you get negative 3. They add to get negative 2.
-3 and +1.
Right. So this is going to factor to x minus 3, x plus 1. So then the trig function is going to factor to sine x minus 3 times sine x plus 1 equals 0. Okay? All right, now let's go back to the algebra. What do I do next once I've factored it?
You set those 2 parentheses to 0.
That's right. Set each factor equal to 0. Well, guess what? That's exactly what I do with the trig functions. So I say sine x minus 3 equals 0 or sine x plus 1 equals 0, and then I solve for each of those. Okay? So add 3 and I get sine x equals 3 or sine x equals negative 1. Okay? Now look to your unit circle. Where is the sine, where is the y value on your unit circle equal to 3? Nowhere. Remember, sine lives between negative 1 and 1. There is nowhere where the sine is 3. All right, how about, is there a place where the sine on your unit circle is negative 1?
270 degrees.
270 degrees. Okay, so then, so the first one gives us no real solution. The second one gives us 270 degrees as our solution. And so that's the answer, 270 degrees or 3 pi halves. But it's down here on the unit circle. Okay? So, but if you ever get, you know, if it says sine x equals any number that's not between negative 1 and 1, that is going to be no solution. You'll get nothing out of that. Okay? All right, so let's have you try practice 1C. All right, so Jocelyn, when you've got it.
Plus 1x minus
Strong. I'm a little stuck at the factoring
Minus
part
2.
of it.
Okay. So if you had x squared equals 2x, what would you do to solve it? Jocelyn, help me out. So let's go back to algebra. So how would we solve that? Okay, you got to set it equal to 0. And then see, you have a GCF, an x in each one. So you factor out an x. So you have x times x minus 2 equals 0. And then you set each of those equal to 0 and solve. So that's the same thing you're going to do here. You set it equal to 0. And then you have a sign in each of those, a sine x. So you factor out a sine x. And then you have times sine x minus 2 equals 0. So now you set each factor equal to 0. And so you have sine x equals 0 or sine x minus 2 equals 0. All right, so let's start with this one. So where on the unit circle, what's the angle where the sine is equal to 0? Okay.
180 and 0 or 360?
180 and 0. So you now notice, let's see, let's go on your sheet, how it has a bracket on 0 and a parentheses on 360. That means those are the same. So you wouldn't say 0 and 360, okay? But because they're equivalent. So 0 and 180. All right? And then here, where is the sine of x equal to 2?
Nowhere.
Nowhere. So you just toss that. That gives you no solution. So your only answers are 0 and 180 degrees. Okay? Any questions on that? All right. So no, let's not do that. Let's go ahead. Okay, so just for fun, let's go ahead and do that one, just for a little extra practice. Since we didn't get that last one right, see if you can do that one. All right, so Seth, if you get it, let us know. Or if you get stuck, let us know.
I'm stuck.
Okay. Anybody? Can anybody tell me the answer?
I think it may be 1 and 2, possibly.
1 and 2 degrees?
No.
Yeah, probably
One-
not. No. So first we start off factoring this. It's already set equal to 0. So what two numbers multiply to get -2 that add to get -3? See, this doesn't factor. Okay? Now typically I'm not going to do one like this. Okay? Doesn't factor. So how would you solve x squared minus 3x minus 2 equals 0? How would you solve that?
The quadratic formula?
You'd use the quadratic formula, and then when you got to the end, for your x equals blah, 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 you would say secant x equals blah, blah, blah. Okay? But anyway. All right. Well, listen, we're going to stop there, and we'll pick it up the next part on Monday. And anyway, you guys have a great weekend. So Holbrook, I'll set up your 7-2 quiz for tomorrow. Okay?
So I have a question about that problem right there. So when you get to secant, would you change that to cosine, or would you just
So
leave
when
it?
you got to your final answer, if you got like secant equals 2, then you would flip it and say then cosine is 1/2.
Okay, cool. Sounds good. Thank you.
Thank you.